All right, we're trying another new filament today. This one's from Amazon Basics. This is our first Amazon Basics filament. So this is a gold filament. I'd call it kind of a bronze gold compared to the shiny gold we had before. So it's an interesting color. It's a 1 kilogram reel. It's about, I think, 200 millimeters across. We're going to be using our outside holder for this. The nominal temperatures are 190 to 220 for the nozzle and 40 to 55 for the bed. So we'll do a temperature tower as usual. This didn't come vacuum wrapped, but I've had it in my dry box for at least 2 or 3, I think probably at least 3 weeks at 29% humidity. So the humidity should be fine. Let's see how much it weighs. So we'll turn on our scale, change it to grams. So this is going to be the weight including the reel. So it's 1,261 grams. That's typical of what I've seen. I haven't finished one of these 1 kilogram reels yet, but based on the half kilogram reels, I'm guessing this reel weighs about 120 grams. So we're getting a little over 1,000 grams or 1 kilogram of material, which is nice. They're not shorting us. All right, so we'll load this up and we'll do our temperature tower, and then we have another fun torture project that I ran across. We're going to try that. That'll be a new one for us. So, all right. As usual, we're in STScI with our pointy temperature tower. So this one's set up for the Amazon Basics PLA Gold, and it's got a fairly wide range on the reel there for printing temperatures from 190 to 220. So we're going to be spanning that plus extra 10 degrees on each side like we usually do with 5-degree intervals. So we've got it set up here as PLA, so we have the PLA label on here that I put in. So there's a link to this project in the note and the description. So if you want to do your own temperature tower like this, you're welcome to give that a try. And we'll render this and then send it over to Simplify 3D and print it out and see what the best temperature is for this PLA. Okay, here we are in Simplify 3D. We've imported our temperature tower. Remember, it's going from 180 to 230. And we set up our profile already, our temperature profile. So for the platform, the range on the reel says from 40 to 55 degrees C. So this bed seems to have good adhesion, so I'm going to get at the lower end of that, maybe 45, start at that, see if we have any problems. And for the extruder, we need to match up our layers with this temperature range that we've got in our tower. So the base area here is 18 layers thick before it gets to this first bridge here. So start out at a nominal temperature somewhere in the middle of the range, 200. Seems like a good starting point. And then the first temperature is 230. Then you have to put in these manually, but I started with an old one that I had set up already and just added to it. So each bridge is another 35 layers. So we need to increment this layer number by 35 each time. And then we just match these temperatures up with the ones over here, going all the way down to 180. So this is probably our tallest temperature tower we've done so far, by at least one bridge. So that'll take a little bit longer. But we're all set with that. And then we can say prepare to print. See how long it's going to take. It's going to take 2 hour 55 minutes to print this. All right, it's done. So I already took it off the base. It did pretty well. So see a lot of drooping here at the higher temperatures. So that's no good. And also at the lower temperatures. So it looks to me like 205 is about the best. Minimal drooping, and the pointy thingy looks good. I don't see any stringing. I want to compare this to the shiny gold PLA. You can see there's quite a bit of difference in color. So this is more of a classic gold color, and this is shiny. So there's a room for shiny on some things, and this regular gold I think will look good on some other things I'm going to print. So. All right, so now we've done a temperature tower. So we know 205 is our target temperature. We can go ahead and do a bed adhesion test and see how that does. All right, so we're ready to try our bed adhesion test. We've used this before with other filaments. And what this test is how well this filament's adhering to the bed based on the bed temperature we set, which we temperature tower used 45 degrees C, and if all these corners are sticking nicely, then we'll know that's a high enough temperature. If it's too hard to get off, then the temperature is too high. And it's important to watch the first layer go down, because you can see if it's not adhering well, it'll be all blobby and so forth instead of just flat along the surface. You can also show how well your bed is leveled, because this is a nice wide rectangle here. We cut the middle out to speed things up. We don't really care about adhesion in the middle. It's all about the corners. We already set up a profile for this filament based on our temperature tower. So we're going to try the bed temperature at 45, and the extruder 205 looked the best on the tower, so we're going to try that. So we just need to send this to the printer, and we'll take 28 minutes, and we'll see how it goes. Over to the time lapse. So we've had a little setback on our bed adhesion test. I think the extruder nozzle is clogged. So if you saw my other video, we had to unclog the extruder for another filament. So we're going to try it for this one too. So we let the head cool down. Now we're going to turn off the printer. We're going to disconnect the head, and we're going to see if we can do a better job at keeping everything together this time, unlike what we did in the video I showed about how to unclog it. The front section, we're trying to keep that all as one unit and not have it all come apart on us. So we're unscrewing these screws in the front, but we're kind of pushing on them so they stay in there. We detect that they're loose, and we just pull this whole thing off as a unit, trying not to lose any of the spacers this time. And keep everything together. So everything's together as one unit this time. So we'll try to put this over to the side instead of taking it all apart. See if we can balance it over here. That's not done come apart. Okay, it'll stay here. I'll just hold it there. Alright, then we're going to take the motor off like we did last time. Now we're going to turn it back on and heat this up, and then we'll use our pokey thing to unclog the head. I can see some filament sticking out here on the top, so should be able to push that down inside hopefully. So now we need to heat it up, and we'll get the filament out, and then we'll start over again here. Alright, so I've heated the extruder up to 205, which is what our printing temperature is for this filament. And like I said, meanwhile I've just been holding this fan assembly and heat sink over here. Now we're going to try to push this down using our pokey thing. Let's see, and get the filament to come out at the bottom. This is the one to go. So we're going to try heating up higher, up to maybe 240 is the maximum temperature for our extruder. So we'll heat up to 240, and then we'll see if we can get it out that way. Alright, now it's up to 240. Again, I'm just holding this fan and heat sink over here, and the fan is going, but it's not. My finger's not really in danger because it's got a grill on there. So we're going to try pushing harder this time and see if we can get it to come out. Hopefully, it's a high enough temperature. Get it out of here. Pushing pretty hard, nothing's happening. That's not good. Pushing pretty much as hard as I can. It's not coming out. Well, let's see what else we can try. I'm gonna try pushing down with this awl and see if that can get more pressure with that. Afraid though, I may have to take the nozzle off at this rate. Pushing down pretty hard. Oh, there it goes. It kind of popped through. Maybe that did it. Now we'll try this. It's like a little barrier there. Yeah, now it's working. Okay. You can see the filament's coming out. So a little plug of it got stuck there right as it went into the block here. And we'll try pushing this through some more. This thing is getting all clogged up. It's got a big blob on it now. I have to cut that off, I think. Let me work on cleaning this up, and then we'll push it through some more and see if we can get it all unclogged. Residual filament off of this poker thing. That was left over from last time. That'll give us a clean push into the extruder head, and we did that by scraping it with this spatula that came with the printer. So this has got a really sharp edge on it. We use this when we're having trouble getting stuff off of the print bed. It's good at getting the last little residual filament off of that. So we're just heating up our head. We're going up to 240 again, which is the maximum, just to make sure we get as much as we can out of here. I think most of it's out already, but we'll just have to see. And then hopefully we can go forward. Now, this particular filament this is the cheapest filament I've bought. I think it was only $22 per kilogram. Most of the other ones I've been buying around $30 to $35. So it could be because this is cheap filament. I've heard of other problems about cheap filament causing clogs, but hopefully it was because I ran the temperature tower down to only 180, and that was kind of marginal for this filament in this printer. So we're not going to run it at that low of a temperature again, so hopefully we won't have any more clog problems. Okay, so we heat up to 240. We're going to push down. I think we got everything out of there, yeah. Alright, so everything's out. So now we'll go back, and there's a little bit came off on this thing. We'll go back and load the filament and try again on the bed adhesion test. Hopefully this is going to solve it. If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is STScI signing out, and keep looking up.